How does sequence-to-sequence architecture work in deep learning? Imagine trying to translate a sentence from one language to another or converting a spoken command into a written response. How does a computer do that? That's where sequence-to-sequence architecture comes into play. It's a clever way for machines to understand and generate sequences of data, like words or numbers. This architecture mainly uses two parts, an encoder and a decoder. The encoder takes the input sequence, such as a sentence in English, and processes it step by step. It uses recurrent neural networks or similar models to read each word in order, capturing the meaning as it goes. After processing the entire input, the encoder creates a fixed-length summary called a context vector. Think of it as a compact note that contains the essence of the input. Once the encoder finishes, the decoder begins. It uses that context vector to generate the output sequence, one element at a time. For example, if translating from English to French, the decoder produces one French word after another. It considers the context vector and the words it has already generated to decide what comes next. This process continues until the entire output sequence is complete. One of the biggest challenges with early sequence-to-sequence models was that the fixed-size context vector could limit performance, especially with long sentences. To fix this, researchers added an attention mechanism. This feature allows the decoder to look back at different parts of the input sequence while generating each word. It's like having a spotlight that highlights relevant parts of the input, making it easier to handle complex or lengthy sequences. Training these models involves showing them many pairs of input and output sequences. The model learns to predict the correct output by adjusting its internal settings to reduce errors. Over time, it gets better at translating, summarizing, or generating sequences based on what it has learned. You can see sequence-to-sequence models at work in many areas. Language translation tools, chatbots, and even systems that generate code or creative writing use this architecture. For instance, language models like ChatGPT use similar principles to produce human-like text. Productivity tools also relying on these models to summarize documents, translate text, or craft responses automatically. In essence, sequence-to-sequence architecture works by encoding an input sequence into a compact form and then decoding that into a new sequence, with attention mechanisms helping it focus on the most relevant parts. This approach powers many of the AI systems we use today, making communication between humans and machines smoother and more natural.